Hello everyone. In this segment, we are going to estimate the product moment of inertia for the triangle ABC. The base is equal to B and the height is equal to H, and there are two intersecting axes X and Y. They are intersecting at point A. If we drop perpendicular line from point C to the base AB, it will be intersecting at point D with distance to the left equal to A. For the IXY, we can consider this triangle ABC as composed of two right angle triangles. The first one, which is triangle ADC, we call it triangle number 1, while the second one is a triangle BDC, we call it triangle number 2. From the previous calculations, we have IXY for the first triangle as estimated at IXY for axes X and Y passing by the left at the intersection of the hypotenuse to the base, and the value is equal to the H squared multiplied the base squared divided by 8, and our base in that case is equal to A, so we have the expression of IXY equal to H squared by A squared divided by 8. While for the other triangle, triangle number 2, we have a base equal to B minus A, which is left from B after subtracting A, and the height equal to H. And our calculation normally for two intersecting axes X and Y, which is passing by the base and the opposite side of the triangle, which means that we cannot utilize the IXY estimated for that axis because it will be called YDC. Anyway, the IXY for the Y passing by the DC equal to the base squared by H squared over 24. In that regard, our base is B minus A. So it will be B minus A to the power of 2 divided by H squared divided by 24, while IXY as a CG is minus the base squared H squared by 72, which means that it is equal to minus B minus A squared multiplied by H squared over 72. In order to estimate the IXY for the axis Y, which is apart by distance equal to A, we are going to utilize the IXY of the CG. Then we are going to add the area multiplied by X bar multiplied by Y bar. So our final IXY will be the IXY from the first triangle, which is H squared A squared over 8, plus the IXY CG for the second triangle, which is minus B minus A all squared H squared over 72, plus the area, which is 1/2 B minus A multiplied by H, by X, which is the distance from the CG, normal distance to X and Y axes. The first X distance will be A plus 1/3 B minus A, which will give us 2A plus B divided by 3, and the Y, the height in the Y direction is equal to the H over 3. Since we have the 72 here, and we have denominator is 3 by 3 by 2, which will give us 18, I'm going to convert it to 72 by multiplying by 4 divided by 4. So we have a common 72 in the denominator, and we have here B minus A multiplied by H squared as a common numerator factor. We open one bracket. We have here minus sign, so it means that of minus B minus open bracket B minus A squared, which means that we can, after taking B minus A out, we have still minus B minus A inside bracket. And for here, since we introduced the 4 in the numerator, then we are going to multiply 4 by 2A, which is 8A, plus 4 by B, which is 4B, summing together, we have minus b plus 4b is 3b, and we have here minus by minus plus a plus 8a, which will be 9a. We will introduce again and rearrange. We have h squared a squared over 8 plus b minus a h squared over 72 multiplied by 3b plus 9a. We have a common factor of 3. We move to the second slide. We are getting the 3 out. So we have ixy equal to h squared a squared over 8 plus 3 over 72 h squared, and our new bracket will be b minus a multiplied by b plus 3a. So we have h squared a squared over 8 plus, we have 3 over 72 will give us 24, 1 over 24. And here the product of two brackets will be b squared minus ba plus 3ab minus 3a squared. We will find that if we make the denominator as 24, we multiply it here by 3, divide by 3. We have plus 3a squared plus b squared plus 2ab minus 3a squared. They will cancel each other. We left with ixy equal to h squared over 24, open bracket. Inside will be b squared plus 2ab, and that is our expression at the end, but we have a common b inside the bracket. We'll get it out, so we have bh squared over 24 multiplied by b plus 2a. There is another expression utilizing the area, so we can readjust this term by considering that bh squared over 24 composed of 1/2 bh over 12 h multiplied by h, and our bracket still 2a plus b. So we have the first expression ixy bh squared over 24 by 2a plus b, while for the area, which is 1/2 bh, we can write that we take 1/2 bh as a, and then we have this area multiplied by h divided by 12, all multiplied by 2a plus b. This is the ixy for the triangle at two axes intersecting at point A. In order to get the expression for the ixy at the CG, we are going to subtract the multiplication of the area by the distance xcg, ycg as follows. Here we have the xcg equal to the a plus b divided by 3, while the y bar equal to h over 3. So again, we have our expression, which was bh squared divided by 24 multiplied by 2a plus b, and minus the area, which is 1/2 bh multiplied by xcg, which is a plus b over 3 multiplied by h over 3. In order to make a common denominator by 72, we'll multiply first the term by 3 divided by 3, and for the all this second term we will multiply by 4 divided by 4. Let us check. We have here in the denominator 72, while we have here for the second term 2 multiplied by 3 is 6, 6 multiplied by 3 is 18, and 18 multiplied by 4 is 72. So we have also in the numerator common factor be h squared over the 72. We have here 3 multiplied by 2a, which is 6a, plus 3 multiplied by b, it will be 3b. While here we have a negative sign, negative 4 by a is minus 4a, and negative 4 by b equal to minus 4b. So we are going to sum the inside the bracket. We have 6a minus 4a will be 2a, and we have 3b minus 4b will be minus b. And that is the expression for the ixy at the CG, ix dash y dash passing by the CG for the triangle. Thanks a lot, and see you